All right, here we are on day 25 for the last puzzle of Advent of Code. The door to the historian's chief office is locked. 5-pin tumbler locks, schematics of every lock and every key for for the floor you're on. Here's a bunch of schematics, look like grids. The locks are schematics that have the top row filled and the bottom row empty. Oh, okay. So these two, the top two are locks and the bottoms are keys. You can convert them all to a list of heights. It literally says in the question. So 0, 5, 3, 4, 3, and 5, 0, 2, 1, 3. So in the first four columns, the pins and key don't overlap. However, this key cannot be made for the lock because the rightmost column overlaps. So the sum of each column will give us whether this is a viable option or not. Apparently, there's a lot of them. So in this example, the number of unique lock key pairs that fit together without overlapping is any column. So without overlapping, but not necessarily exactly fitting. And we have a whole ton of them, so we're going to need some form of a parser here. So I guess let's start reading them in. I don't know why this says this. This is like kind of implying that we have too many to actually just check manually, but I guess we'll write our first parser. So we'll just create day 25. And we've got our test input. Let's see, part one. Which ones do we have here? In this example, converting locks to pin heights and keys to pin heights. So here's our input. We're going to process this into something. So I guess let's start off with a parser. So maybe we do type. That makes this a struct and this an enum. So we have locks and keys, and our pins are I32s. All of our pins are going to be positive, but I'm going to use I32s for the moment. And then from this, we probably get a vec of devices, which would mean that this is going to be an alt key lock input, many one. Obviously, we don't have key or lock written yet. They're going to be very similar, but they have different start conditions. So we pull in iResult, we pull in many one, alt. Each of these is going to return a device if it works. Types all line up. So then we get what? Are these always the same? I guess 1, 2, 3, 4, 5, 6, 7 height. They're currently always 7 height, always 5 wide. So we could even do like 0, 5 here, right? Like this could be an array of I32s instead with a length of 5. So we can initialize pins to do an array of 5. So we don't really need to do this generically. We could hard code certain things here, right? Like this could be tag input, right? And this has to succeed. If it doesn't, then we don't have a lock. Once we know we have a lock, we'll initialize the pins, make this mute. So if we create a parser here that is initialized with these pins. So with my current parser, I'm getting one more than we need in all slots because we're doing heights, I guess. I guess that's because this one doesn't count. So for the first and last section, we're not supposed to count them, I guess. I think luckily that just means we bring these down by one. We used I32, so this shouldn't be an issue. And then we get 05343, 12053, 50213, and that's all correct. So I had a little bit of fun today with the parsing. We have something that looks like this. So the approach that I wanted to take was this first line defines whether it's going to be a key or a lock. So we look for this line first, and that determines whether the key or the lock parser is going to succeed. And then we use an iterator parser to just glop everything else up, and we enumerate over that iterator to fill in the indices in a array. And then this is just a separated list, which returns that. So the separated list is all of the chunks. So it's like this and then the next one with the line ending here. And then we parse either a key or a lock. The key and the lock are both very similar. They could be the same parser with different initialized values. So I wrote a lock to check to see if that hash was there, that 5 hashes in a row. The key by correspondence checks to see if there are 5 empty spots in a row. My understanding is that keys will always have that buffer. So if we end up with a key that goes all the way to the top for some reason, then that's just a broken input. So we do this check for that first line. This tag parser in both cases will fail if that's not true. So looking back at our alt, it'll try to do a key. If that first line fails, it'll try a lock. If that fails, then we're basically done. Otherwise, we just chop that line ending off and make sure that we're about to look at a dot or a hash. And then we write this accumulate pins with an initialized value. This is a custom parser that returns an array, a 5-element array of I32s, which we can then fill out our struct with. The accumulate pins parser, I originally wrote to take a slice of pins, but I decided to rewrite it. And I think as a result, this actually gets simpler overall for the type signature and such. In our case, accumulate pins, which we can take this lifetime off to. Accumulate pins takes an initialized array of 5 elements. We make that mutable because we're going to use it moving forward. And we return a closure that implements fn mute, which should look familiar if you're familiar with num and have been watching the videos over the last 25 days. This takes a string slice as our input. So it's the same thing that we're doing here, input string slice and I result return. So it's input string slice, I result return. In this case, we happen to specify the error here, but for our current usage, we actually don't have to. We can write it almost exactly like we have our other parser. So we've got a string slice and a return value of this array. We use a closure here and an iterator to apply a parser repeatedly. And this is legitimately just an alt parser for dot and hash. We just keep pulling those into our iterator according to the input that we're given. And we're looking for an optional line ending at the end because the final key or lock won't have that line ending, at least in our test input. This is really a difference between our test input and real input. Our test input never has this line ending and our real input does. So we can take this iterator that we've created, enumerate over it, which gives us all of the I values that we need to insert into this array. We do a mod 5 to get the right slot to put it into, and we add either 1 if it's a hash or 0 if it's not. Finish off the parser, tell it we're done, and return those pins with the rest of the input. Now, I'm pretty sure I could write this a little bit more cleanly, but this is just kind of what I got down. So we're left with a bunch of devices at this point. And if I debug this out, we can see type lock, type key, etc. So the question here then is what counts as an overlap, right? Because we can use extract if again. We used extract if yesterday, so just gonna keep the nightly vibes going, I think. So in lib.rs, we'll drop in extract if as a feature. This will need to be mute. We didn't implement partial equality here, so we need to do that for device type. And I'll just slap eq in here as well, because we do actually have a full equality here. We don't have any nans or anything like that. So should be all of our locks, and then all is left being all of our keys. So maybe we just rename that here. So we have locks and keys. We can validate that by saying, by doing this and realize that I misnamed it. So this is going to be, I guess, lock, not key. And then we end up with locks and keys in the right variables. So with that, it said we need to figure out whether it overlaps or not. I think the answer to that is if the two numbers add and are greater than, what was the height, 7? So I guess in this case, it's if they add and they are 6. No, this is 5. I guess we only get 5 as a distance, right? 1, 2, 3, 4, 5. And because we're starting with the zeros, I think we're good. So if they are 5 or less, then we're good. If we are, yeah. So basically like locks.iter dot Cartesian product keys, map lock key, standard iter zip lock key. I guess lock dot, what did I call this? Pins, key dot pins. Expects a tuple in this closure. Don't need to debug that. We get standard iter zip dot all a b a plus b is less than or equal to 5. And then I guess this is like a filter, right? And then we count that, and theoretically that's our answer, assuming it runs in some, reasonable amount of time. So we're passing in 3. It should be 3. I don't think I set up the test actually. So put in that test, we get a passing value. So we're basically just comparing them all at all times, right? We take the locks, we take the keys, we take the Cartesian product of locks and keys. So we get every lock paired with every key. That's what this means. We filter over lock and key. If lock pins and key pins all add to be less than 5, then we're good. Otherwise, we're not. So theoretically, this is our answer, and it is. Welcome to a gold star for day 25. So if you haven't been doing Advent of Code, the part 2 for day 25 is usually not actually a puzzle. Part 1 is, whatever. It's usually something fairly easy like this so that people can wake up on the 25th and do whatever. And to finish and get this final thing, you need all of the stars. So in this case, you need 3 more. And that's because if we look at my stars, didn't finish off 17 part 2, and I just decided to not do part 21 or day 21 because I wasn't having fun with it. So at some point I might do day 21. I don't know. Having all of the 50 stars will probably get me, and I will probably do day 21 at some point here. I'm definitely going to finish up day 17 part 2, so I'll probably post a video when I make the video for that. This was the reverse engineering day. So the issue that I had in part 2 for this day was I reverse engineered the test program here, and the test program and the actual input need different reverse engineerings. So I had the answer for the test input, and I just need to translate that reverse engineering to the actual input here. But that's really mostly it for Advent of Code this year. So I hope you had a good time. I do this every year, so if you enjoyed it, come back next year. I think that, oh wow, only 1,300 people have finished all 50 stars. Interesting. I wanted to look at my own times though. Personal times. So this is my times for the year. I usually go a bit slower because I'm doing these videos. So especially the ones that are early on that are fairly quick for people, I usually end up taking quite a bit more time to do explanations, to talk about different libraries, whatever, stuff like that. Somewhere in this area is really probably more comparable to my other years. I think my lowest placement this year was 1751 for part 2 on day 16. And I had at least one lower placement last year, but I also had a lot more higher placements, I think. Right? I'll have one of these this year. I had one of these last year, or at least I'll have 3 of these this year because I did 17 part 2 and then day 21 or something like that. So it's cool to see a little bit of improvement here. I don't tend to be somebody who's particularly concerned about leaderboards, but I like seeing my own work year to year. So I think I'm pretty happy with reducing the amount of 10K plus placements that I did, especially in the middle of the year, or in the middle of the month, rather. Whatever day 11 took me a while. So I guess we can consider this like, this one was probably one that I had trouble with. This one was one that I had trouble with. And then this one was one that I had trouble with. So this one for both days, this one for part 2, and this one for part 2. So if you match this to this year, this is basically the same as this year for day 21. And then this is the same for day 17 or whatever. And then I have reduced the amount that happens one time, which is cool. And yeah, you can see that I have day 17 part 2 to do. And I guess day 21 doesn't show because I didn't do it. Would be nice to have a little dash there actually. And then I'll get part 2 up here at some point. And then we get our little 10. So I hope you had a good month. There were definitely ups and downs as there always are. I will, like I said, finish up 17 part 2. I don't know if I'm going to do day 21. Like I said, the finishing the stars thing will probably get me to do day 21. But we'll see. And I'll see you next year. Have a good 2025 and happy holidays.